Hello students, my name is Narendra Singh Patel and you are seeing Theory of Computation. So in last class what we have seen a little bit concept of grammar. So why do we use grammars in computer science? So today we will discuss some other topics of grammars, like we will see what is, we have already seen derivation in last class, so I will continue after derivation. So we will see what is LMD, which is called leftmost derivation, then we will see RMD, which is called rightmost derivation, then after we will see pass tree, then yield of the pass tree, and what is sentential form. Okay, so you all know what is grammars. So grammars are actually combination of VTPS. We have already seen in last class. V is stands for variable or non-terminal. T is for terminals, and P for number of production. So and S for starting symbol. So let me just write down one small grammar. So I have since in last class I have already mentioned that whenever I will use our favorite grammar. So what grammar we will use? We will use this grammar. So just for basic understanding, whatever operations we will perform in this grammar, because this is very simple grammar and very easy to remember. Okay. So let me tell you about LMD first. So what is LMD? LMD is also known as leftmost derivation. So what we will do here, when we have to generate a string or when we have to generate sentence, I can alternatively use both the words, since strings and sentence both are same. Okay. So whenever I have to generate a string from this grammar, so what will I do? I'll use the starting symbol first, as is my starting symbol. So S is giving AB. So this is my first production. This is my first production. Now I have random choices whether to derive a small a or a small b. So I can either derive a small a from capital A, or I can derive a small b from capital B. So what does leftmost derivation tells us? It tells us that whenever you want to derive any string, and if you want to derive it from the leftmost side, then you can use LMD, which is called leftmost derivation. So which is left here? A is leftmost or B is leftmost? So clearly A is leftmost. When we will see, this is my left hand side and this is my right hand side. So capital A is my left hand side. So what I will do? I will replace, since it means small a, small a I can replace capital A by small a. So what I can do? Capital small a is replaced by capital A and my capital B as it is. Now in next step, what I have to do? Since there is only one non-terminal or one variable here, so automatically I have to replace remaining non-terminal. So in that case, this capital B is being replaced by a small b. So a small ab is my string. And what is this? This is rightmost derivation. Here I am deriving rightmost non-terminal first. So what is my rightmost non-terminal? So capital B is my rightmost non-terminal. So therefore I have derived B from it. Now my A is as it is. And in another step or in next step, what I will do? Remaining non-terminal, I will replace it with a small a. So this is my another string. So of course, if you will use the leftmost derivation or rightmost derivation, a string will be same only. So now you will ask me, sir, why are we doing RMD or why are we doing LMD? Cannot we do in random order? So you can do it in random order as well. For example, if you have a grammar like this, A, B, C, D, where A is giving a small a, B is giving a small b, C is giving, we know how to read it, right? Capital S is giving A, B, C, D, or capital S derives A, B, C, D. So I can use any of the words. Capital C is, let us say, it is giving small c, and capital D is giving a small d. So if I use leftmost derivation, what I will do? I will write A, B, C, D first. Then from leftmost side I will have to derive. For example, first of all I have to derive from A. So it will be like a small a, capital B, capital C, D. Then the leftmost. Now what is the leftmost now? since small a is already a terminal now, so we have to replace next leftmost non-terminal. So what is next leftmost of non-terminal? So it is capital B. So small a as it is, capital B I can say, it can be replaced by small b. Now CD as it is. In next step, what I'll do? Next leftmost. So this one is capital C and this one is the small c. Now you must be wondering why I'm not using random derivation. For example, can I not do like this? Let us say my favorite word is or my favorite letter is capital C. So what I want to do is I want to derive capital C first. So this is small c, capital A, capital B and capital D are as it is. So we can also do that. We will not encounter any problem. But while solving complex questions, for example, the question that will be framed by using this concept is calculate the string or generate the string from this grammar. Or you have to identify the string. For example, let me write down, this is the one string, capital X, double Y, ZZ, X, Y, Z. You will get one random question, or you can say a question which is having more than 10 to 15 derivations. So and they will ask you to derive such complex kind of a string. So if you will do random derivation, you might get stuck in between. So that is why I'll recommend you. That is why I'll recommend you to either use leftmost derivation or rightmost derivation. It will make. So by using a random derivation or while solving the answers, that method will be typical. So everyone prefers either you use LMD mode or RMD mode. Okay. So that was about leftmost derivation or rightmost derivation. Now we will see what is parse tree. So parse tree is actually tree representation of this derivation. So for example, this is your starting symbol. From starting symbol you have to derive all these strings. So the tree representation of derivation is actually known as parse tree. So what I can do, what we can derive from S. So S can S capital and capital B can be derived from S. So we can derive AB. Now I can either go for leftmost derivation or I can go for rightmost derivation. So if I'll go from leftmost derivation, so what I can say, I can replace small a from capital A and my B as it is, and in next step I can say this I can derive. So the same string AB I am deriving from my starting symbol. So this is my string, and this representation, you can see this representation as it is in tree form or in tree shape. So this is actually known as parse tree. This is called parse tree. Alternatively, you can also call it as derivation tree, parse tree or derivation tree. So what is leftmost derivation? Deriving any string from leftmost side is known as leftmost derivation, and deriving any string from rightmost side is known as rightmost derivation. What is parse tree? Tree representation of deriving any string. Either you can use LMD mode or you can do RMD mode. So that is known as parse tree. Okay, so let me give you the definition first. So what about the LMD? So LMD means leftmost derivation. So it is a derivation in which leftmost side non-terminal is replaced by its corresponding right hand side production. So what is the right hand side production of leftmost side non-terminal? So as you can see, right hand side part there is A mentioned and left hand side part is A. So it is a production in which leftmost side non-terminal is replaced by its corresponding right hand side derivation. So here we have replaced small a. And in same, what does rightmost derivation do? It is the production in which rightmost side non-terminal is getting replaced by its derivation. So that is LMD, that is RMD. So what is parse tree? The tree representation of any derivation is known as parse tree. What is yield of the parse tree? So The leaf nodes which you encounter in your parse tree are known as yield of the parse tree. So here what is yield? So 2 is the yield here. So what is yield? Okay, so let me write down the definition of yield of the parse tree. The total leaf Okay. Now what is sentential form? So this is the definition of yield, that total leaves in the parse tree are known as yield of the parse tree. So how many total leaf nodes are there? So this one is one leaf node, this one is another leaf node. Okay, let me give you another example. So for example, okay, I am modifying this grammar a little bit. So let us say I am doing, is giving this. So I am deriving any random string from this grammar. So let us say S is giving capital AB. Now you can replace A either by small a or by small a capital A. So I am doing this production here. Small a capital A. My B is as it is. I can again replace this small a by small a capital A. My B as it is. And now I am replacing this A by small a, my B is as it is, and now I am replacing this B by small b. So what is the yield of the parse tree now? So all the leaf nodes. So what are the leaf nodes? This one is a leaf node, this one is a leaf node, this one is a leaf node, and this one is a leaf node. So do you think this one is a leaf node? No. Why? Because this one is already connected. So this is not a leaf node. Why? Because it has children here. So this is not a leaf node. So is this the leaf node? No. This one is also not the leaf node. This is also not the leaf node. Is this the leaf node? Yes. This is my leaf node. So 1, 2, 3 and 4. There are 4 leaf nodes, so we can say 4 is the yield of this parse tree. Okay. So what is the string? So reading the yield from left to right. So this is my string. So what it is? Triple AP. So reading the yield from left to right gives you a string or sentence of the parse tree. So the string or sentence that you have derived from this grammar is this. So this is my yield. Okay. Another thing is sentential form. So what is sentential form? So sentential, any string or any derivation derived from a starting symbol is actually known as a sentential form. So what I can say, yes, S is one sentential form. Now this intermediate representation, you have replaced capital A, capital B by S. So this intermediate representation is also known as sentential form. This intermediate representation, since this representation, from where this representation comes, this representation is ultimately came from a starting symbol. First you have replaced capital AB from S, and then you have replaced small a, capital A from A, and B is your as it is. So all these intermediate, or you can say start or end. So all these intermediate, you can say either nodes or you can say string. All these intermediate strings are actually what? Actually known as sentential form. So all these intermediate derivations are actually known as sentential form, and so from capital S to your string that you have derived, all these are known as sentential form of the parse tree. Okay, so let us proceed further. Okay students, so let's solve several questions so you will get better idea. Okay students, so let's solve some questions so you will get better idea of how we are going to use grammars. So there are two types of questions we commonly get from grammars, like identify the language generated by following grammars and construct the grammar from the following language. So here there are two grammars written, so let's talk about this grammar first. So from this grammar you have to identify which kind of language is getting generated from this grammar. And from this question there is one language written, so you have to form one grammar for this language. So let us solve this question first. So this is the question. Capital S is giving two productions. One is this one and another one is this one. So capital S is producing either small a and with capital A and only small a. So what you can do is, let us try to find out the minimum string which can be produced from this. So let me make the past tree for better understanding, because this is the first question. So capital S. So now I can derive either this production or this production. So if I derive this production, again I have to, okay, so this is an incomplete question. So there is one more production related to this. Okay, so this question is this now. Let me make little change. Not a. Okay, so this is capital S is giving small a capital S. Okay, so if I choose this production, what I have to do? I have to again replace my capital S. So if I want to limit this production to just one, what I can do is I can derive only this one, only this production. So S is giving small a. So can you derive another derivation from this small a? No, you cannot. Why? Because this is the terminal, and terminal does not replace by anyone. So the minimum string that you got is small a. So here I am writing how many strings we can get from this production. So the minimum string we are getting is small a. Okay. So this was my first production what I have used. Now second what I can do is capital S is giving. Now if I again take the same production that capital S is giving small a, then this will again repeat the same story. So now I will try to take another derivation. So capital S is giving small a and AS. So it is giving small a and capital S. Now if I want to restrict it to just for two symbols, so what I can do is I can make it stop by using this production. Now this will stop. So what it will give is yield. What is yield? Yield is the leaf node. So small a and small a, they both are leaf nodes, and the string that we are getting is double A. So another string we are getting is double A. So if I proceed further, I can again replace it by AS. So we are getting 1A. We are also getting double A. Can we get 3 A's? Yes, we can get 3 A's by using this type of production, and ultimately so on we can go further and we can get any number of A's that we want. So we also can get triple A, we can get 4 times A, 5 times A, any number of A's we want. So ultimately, after analyzing all these strings, I can say that this grammar is producing that strings in which A can be followed by any number of A's. So what I can say is this grammar is giving me a language L is equal to A plus. What is the minimum number of string that you can produce from this grammar is small a. So you have already seen in finite automata that A plus is a complete language over A, in which the minimum string what you will get is single A only. So you will know what is A plus, right? A plus is all the combinations of A. It can be A, double A, triple A, or so on, any numbers of A. So this is the language we are getting from here. So this was the first question. Can we say it is a complete language? No, it is not complete. Why? Because you cannot produce epsilon from here. What is epsilon? A string of length 0 is known as actually epsilon. You must have heard it about in first class. So this is the epsilon, but epsilon is not producing from this grammar. So this is not the complete language of A, but we can say, yeah, it is producing any number of A, any combination of A, in which the minimum substring will be small a. Okay. Now let me do the second question. It is saying S is giving AS or BS or epsilon. Okay. So here I am making the derivation. Now the minimum string what I can get is epsilon. So S is giving epsilon. So this is my minimum string. Okay. Other than epsilon, what can I get if I use this production? So what I will get here? AS. So can I again replace S by epsilon? Yes, I can. So what is the minimum string? A followed by epsilon is A only. So I am getting A. Okay. So if I replace this S by AS, what I can get is here I can again replace it by epsilon. So what I can get is I can get double A. Same I can get for any number of A's. Okay. Let me just change my production. So what if I use BS first? I can do that also. So BS. Oh my god, this is same as just like AS. So from AS we were getting any number of A's. So from this we can also get any number of B's. Like this only. So I am getting any number of A's with epsilon, and also I am getting any number of B's. Like single B, double B, triple B, and so on. Okay, let me try for more combinations. So this is giving S is giving what? Let us say S is giving here AS now. Now if I replace this capital S by BS, what I can get is, I am getting A, then B, then if I say AS, and here I can replace this as by epsilon. So what I am getting is, I am getting ABA. It means from this grammar we can also generate a string in which my first element would be A and then B and then any combination of A, or we can also derive any combination of B also. For example, if I replace this by BS, so we can also get BS. Can I also derive one string in which my first element or the first letter of my string would be B? Of course I can do that. For example, I have to do BAB. So what I can do is, instead of writing AS, what I'll do here is I will use BS. So here my first terminal would be small b, and I can do AS here, and so on. We can get any number of string. So can we get any string or any combination of A and B? Yes, we are getting single A, we are getting every combination of A, we are also getting every combination of B, and we are also getting multiple combinations of A and B together. So I can say this grammar is sufficient to derive any string which is the combination of A and B. So I can say yes, and also it is giving you epsilon. So we can say yes, this is giving A plus B whole star. So this is giving me complete language over A and B, and we can derive any string from this grammar. So this is how you will solve. These are level 1 question only, not level 1 also. These are level 0 questions. Okay, in next class we will see further more complex question of this. But this is how you will going to solve these questions. So let me do this question also. So these are type 1 question in which you have to identify the language from the given grammar. Now I am trying to solve second type of questions. So what it is saying, you have to derive one grammar in which you can produce this string. Okay. So what it is saying, after reading this, what I can analyze is, it is saying you have to derive one language which should be combination of A only. So here if you talk about input signals, so input symbols are just one. Okay. You all know input signals. So over the symbol A, you have to derive this kind of language. Okay. So just for my understanding, can you say what type of languages or what type of strings you can derive from here? So you can say you can derive A or double A or triple A or any combination of A. If I say A raised to the power 0, what does it mean? It simply means epsilon. You all know epsilon, I hope. Because in theory of computation and finite automata part, I have briefly discussed about epsilon. So, you can also derive epsilon as well as any combination of A. So, I can say this, what is it is saying? It is saying A star means complete language of A. Okay. So, let me just write down my starting symbol first. So, as is my starting symbol. Now, you have to derive what is the minimal string you are getting epsilon. So I am writing epsilon first. So epsilon you can derive. Okay. What next? You can derive A. So if I write A and just after A, you can derive any number of A. You can also derive any number of double A also. You can also derive triple A also. So instead of writing all this, if I say A followed by S, and from this S you can also replace this as by again AS, again AS, again AS. So what you are saying indirectly is, since you are replacing this capital S by AS, so you can say, or you don't have to write all these terms again and again. So what you can say is, you can say this should be the grammar for generating the complete language of A with epsilon. So whenever you want to stop, you can just use epsilon. So this is how you will solve these kinds of questions. Okay. So I hope you will understand all the concepts which I taught today. So we were just seeing the very basic questions of grammar. So we have seen leftmost derivation. We have also seen what is rightmost derivation. We have also seen what is derivation tree or parse tree. We have also seen what is yield of the parse tree and how to say what string is getting produced by that grammar. And we have also seen what is sentential form. And then at last we solve two types of questions in which you have given one language and you have to make the grammar of that given language, and you have also given one grammar and you have to see which language is getting derived from that grammar. So in next class what we will see types of various grammars. Okay, so I hope you have enjoyed the session. Thank you very much.